Hello everyone, welcome to Chemistry Academy. Today we are going to discuss the position of tetrahedral void and octahedral void in HCP crystal. So we already know about this hexagonal prism in HCP crystal, right? We have two type of unit cell, Brevias unit cell, which is a parallelopipe, and this is hexagonal prism. So the atom present at the corner of this hexagonal prism has a contribution of 1 by 6 because this angle is 120 degrees. So two more hexagonal prism is required to cover 360 degree, and we can place three more hexagonal prism over these three. So its contribution is 1 by 6. So all the atoms which are present at the corners of the top and bottom face has a contribution of 1 by 6. The atom present at the center of this top face and bottom face is shared between two hexagonal prisms, so its contribution is half. Right here also it has a contribution of half. And the atoms present at the center of this hexagonal prism, their center is inside the hexagonal prism, so its contribution is 1. So from here, if I calculate that, what is the number of atoms per unit cell? That is equal to, there are 12 atoms at corners whose contribution is 1 by 6. There are 2 atoms at the bottom and top face whose contribution is half, and there are 3 atoms in the center whose contribution is 1. So if we simplify this, this is 2 plus 1 plus 3. So the total number of atoms per unit cell is equal to 6. We are going to discuss the closest pack of 3 dimension, because we know that FCC crystal and SCP crystal is closest pack of 3 dimension. In order to make closest pack of 3 dimension, we should start with closest pack of 1 dimension, and on repeating this closest pack of 1 dimension, we can make closest pack of 2 dimension. So close packing of 2 dimension is of 2 type. The first one is known as a square packing. So here this is closest pack of 1 dimension, and if I am repeating a layer over another layer, another layer and other layer, right, by this we can make a square, right? The unit cell of this is a square. If I repeat this square again and again, we can occupy the whole area. So the packing fraction of this square packing is equal to pi by 4. If we further simplify, we can write that this value is equal to 0.785. 78.5% of the area is occupied by atoms in square packing. In another way, when we are discussing about hexagonal close packing of 2 dimension, in this, if this is a B layer, the A layer is placed in the gap of B layer, right? So here the layers are more nearer to each other, the packing fraction is more. If I calculate the packing fraction of hexagonal close packing in 2 dimension, that is equal to pi by 2 root 3. And if we simplify further, from there we are going to get that this value is equal to 0.906, means 90.6% of the area is occupied by atoms in this type of packing. So in close packing of 2 dimension, hexagonal close packing is the closest packing in 2 dimension, right? Because its packing fraction is greater than that of square packing. So now it's obvious that if I have to make a closest pack of 3 dimension, I should start with the closest pack of 2 dimension, right? So if I want to make closest pack of 3 dimension like HCP, I should choose closest pack of 2 dimension, which is HCP of 2 dimension, right? So this is a layer which is closest pack of 2 dimension, right? You can see here that if this is A layer and this is B layer, we can say that the atoms in B layer is in the gap of A layer, right? So this is 2-dimensional hexagonal close packing, and now I am using another same layer. This is also 2-dimensional hexagonal close packing. I can place the B layer over A layer in 2 ways, right? If I am exactly placing the position of atoms of B layer over A layer, right, like this, So here this is a layer, then this is also a layer, because the position of atoms are matching. If I am placing like this, the gap between these two layers is more, right? So packing fraction is going to be less for this. If I want to improve the packing fraction, I should place the B layer in the depression of A layer. So here the gap is less and the packing fraction is more, right? So this is A layer and this is B layer. In order to make hexagonal close pack of 3D, I have to take another layer, and the position of this third layer is exactly the same as the position of first layer. Since the position of the atoms in the first layer and third layer are same, these layers are known as A layer and A layer. So ABA type of packing, that is hexagonal close packing of 3 dimension. So let me explain you better. We know that in hexagonal close packing, a unit cell is known as hexagonal prism. So this is exactly hexagonal prism. So this triangle is basically a close packing of 2D, hexagonal close packing of 2D, because this triangle when repeated 6 times will form this hexagon, right? So the packing fraction of this and packing fraction of this will be same. So if I am placing the B layer in depression of A layer, right? And again if I am placing this A layer, then we are going to exactly get hexagonal prism. So we are going to get this hexagonal prism in this way. So this is hexagonal prism unit cell. And we have counted that the number of atoms per unit cell is equal to 6, because the atoms at the corners has a contribution of 1 by 6, and these are 12 in number. So 12 into 1 by 6 is equal to 2, and there are 2 atoms at the top center and bottom center whose contribution is half. So 2 into half is equal to 1, and there are 3 atoms whose contribution is 1. So we can say that 2 plus 1 plus 3, total number of atoms per unit cell is equal to 6. Now we have to study the position of tetrahedral void and octahedral void in HCP crystal. So first we have to understand that what is tetrahedral void. So tetrahedral void is a vacant space which is equidistant from 4 atoms, and if we combine those atoms, there is a formation of a regular tetrahedron. So we can see here that this is a equilateral triangular base. If we connect the center of all these atoms, an equilateral triangle will form. And if I place this atom, so the center of these 4 atoms, when we combine, there is a formation of a regular tetrahedron, and we can see here that there is a gap, right? So this gap is surrounded by 4 atoms, and this vacant space is equidistant from these 4 atoms, and on joining these 4 atoms there is a formation of tetrahedron. That's why this void is known as tetrahedral void. Tetrahedral void is a vacant space which is equidistant from 4 atoms. On joining those 4 atoms there is a formation of a regular tetrahedron. Similarly, when we are going to discuss that what is octahedral void. So octahedral void is a vacant space which is equidistant from 6 atoms. On joining those 6 atoms we are going to get a regular octahedron, and we know that octahedron को हम क्या कह सकते हैं? We can say that it is a square bipyramidal geometry also, right? So here, in order to make that octahedral void, we have taken a triangle, and this is a equilateral triangle, right? So if we combine the center, or if we join the center of these 3 spheres, we are going to get a equilateral triangle. So the vertex of this equilateral triangle is towards you and the base is towards me. Now I am taking another equilateral triangle. The base of this equilateral triangle is towards you and the vertex is towards me. I can say that these 2 triangles are opposite to each other and the position of atoms are not matching. Now I can see that there is a vacant space over here. I can see through my eyes, right? You can find my eye, right? So this is a vacant space where we can say that it is equidistant from 6 atoms. So on joining these 6 atoms, there is a formation of an octahedral void. I will show you that why it is also known as square bipyramidal geometry. So in order to show you square bipyramidal geometry, we can take this as, if I am saying that this is one atom, this is an one atom, and these four atoms I am taking, right? If you see these four atoms, if I combine the center of these atoms, there is a formation of a square, and this one is a vertex, and this is also the opposite vertex. So if I combine this square with this vertex, this is a square pyramid. And if I combine this square with this vertex, this is also an square pyramid. So this is a square bipyramidal geometry. That's why we say that octahedral geometry is also known as a square bipyramidal geometry. So now you are aware about the definition of tetrahedral void and octahedral void. Now we are going to discuss the position of tetrahedral void and octahedral void in SCP crystal. So this diagram is taken from NCERT, right? And with the help of this diagram, we are able to explain the position of tetrahedral void and octahedral void in hexagonal prism, right? So I'm going to discuss with the given diagram, which is taken from NCERT book. So we can say that the position of tetrahedral void and octahedral void is within JEE Mains and JEE Advanced syllabus. It is not out of syllabus, right? There are two layers shown here. One with a dark circle and the other layer with a lighter circles, right? So I am showing you the diagram here. So we have made a regular hexagon with the help of these dark circles, right? So these 6 circles at the corners of the regular hexagon, and one circle is present at the center of this regular hexagon, right? So these are a layer. We can say that this is forming a layer A. Then there is light circles, right? I am drawing, there are 3 light circles inside this regular hexagon, and all the part of this circle is not inside the regular hexagon. So this is one circle, right? Then the other circle is this one, and this is the third circle, right? So this is forming B layer. So A layer and B layer, and between A and B layer we are going to discuss that what is the position of tetrahedral void and position of octahedral void. So here first we are discussing about this atom present at the center of regular hexagon. You can see that corresponding to this atom there are 4 positions of tetrahedral void, right? So let us understand with the help of this model that how these 4 tetrahedral voids are there. So I am discussing about this pink ball present at the center of regular hexagon, and now I am going to place this again, this is also HCP of 2 dimension. I am going to place in the depression of the first layer. So you can see that this will form an equilateral triangle, and this atom is the vertex of that. So this is a tetrahedral void. So tetrahedral void is present here, and I can say that this regular hexagon, if I take these 3 atoms, right, the center of these 3 atoms will form a equilateral triangle. If I am going to place this atom will act like a vertex of that regular tetrahedron. So this atom and these 3 atoms will form a regular tetrahedron, and this is the tetrahedral void. So same way I can say that there is a tetrahedral void over here, and there is a tetrahedral void over here, right? So one tetrahedral void over here, which is shown here, right? This tetrahedral void, you can see that it is here, and there are 3 tetrahedral voids, right? 1, 2 and 3, which is shown here. These all tetrahedral voids are present inside the hexagonal prism, so their contribution is 1. Now till now I have discussed the position of tetrahedral void with respect to this atom present at the center of regular hexagon, and it is between A and B layer. A similar layer will be there above this. So same way I can say that now this atom present at the center and these 3 atoms at the center of hexagonal prism is going to form a regular tetrahedron, and the center of this regular tetrahedron will be a tetrahedral void. So we can say that along the axis of this hexagonal prism, if I am touching the top face center and bottom face center, through that an axis is passing, and through that axis there are 2 tetrahedral voids, and then we can say that there is one tetrahedral void here, and already discussed one tetrahedral void here, right? So with respect to each atom present at the center of this hexagonal prism, there is one tetrahedral void above it and one tetrahedral void below it. So now I can say that corresponding to this position there are two tetrahedral void, corresponding to this position there are two tetrahedral void, and corresponding to these two positions there are two tetrahedral void. All these tetrahedral voids are present inside the hexagonal prism, so their contribution is going to be 1, right? So if I say that if this is the atom, this atom is surrounded by how many tetrahedral voids? So we can say that this atom is surrounded by 8 tetrahedral void, right? So each atom is surrounded by 8 tetrahedral void. Similarly, if we discuss the position of octahedral void, right? So first we are going to see that in this diagram, this is an octahedral void, this is an octahedral void, and this is an octahedral void, right? So here we can see that what are the positions of octahedral void we can discuss, right? So this is a triangle, right? The base of this triangle is towards you, and the vertex of this equilateral triangle is towards me. And now here this base is towards me, and there will be another atom, so which is acting like the vertex, which is towards you. So this position is position of octahedral void, right? So in this structure you can see that this is an octahedral void, this is a tetrahedral void, again this will be an octahedral void, this is a tetrahedral void, this is an octahedral void. So that octahedral void is shown here. This is an octahedral void, this is an octahedral void, and this is an octahedral void, right? Similarly, we can find out that if we place another layer to form the hexagonal prism, same way we can discuss that this will be a position of octahedral void, this is a tetrahedral void, this is a position of octahedral void, this is a position of tetrahedral void, this is a position of octahedral void, this is a position of tetrahedral void. So all these octahedral void, if you see, with respect to this there are two octahedral voids, with respect to this there are two octahedral voids, with respect to this there are two octahedral voids. So total number of octahedral voids in this prism unit cell is equal to 6, and they are inside, so their contribution is 1. This atom is surrounded by, the atom present at the center of regular hexagon is surrounded by how many octahedral voids? So each atom is surrounded by 6 octahedral voids. This line is given in NCERT, right? I have taken this line from NCERT, and this is very important for JEE mains as well as JEE advanced. Let us discuss this line. In SCP crystal, the 3 atoms present in B layer is not completely inside the hexagonal prism unit cell. This line can be explained by the diagram given inside the NCERT. You can check this diagram, right? With the help of this diagram, we are able to explain that this is going to be the correct statement. The position of 3 atoms which is inside this hexagonal prism, right? We are talking about 3D. So on 2D we are looking at this hexagon, but basically we are discussing about hexagonal prism. So we are saying about these 3 atoms, which is the center of these atoms here. This is inside the hexagonal prism. So one atom is this, the other atom will be this, and the third atom is this. So center of all these 3 atoms is inside the hexagonal prism, right? But you can check here that this portion is outside the hexagonal prism. Some part of this atom is outside the hexagonal prism. Similarly, some part of this atom is also outside the hexagonal prism. Some part of this atom is also outside the hexagonal prism. But the number of atoms per unit cell is not going to change. Why it is not going to change? There are many ways to explain this. One way is that कि अगर ये जो 3 atoms अंदर है, इनका कुछ पोर्शन बाहर है, तो 3 atoms ऐसे हैं जो बाहर है, उनका सेम पोर्शन यहाँ अंदर एग्जिस्ट कर रहा है. इसका कुछ पोर्शन बाहर है, तो ये जो एटम है जो इस प्रिज्म के अंदर एग्जिस्ट नहीं कर रहा है, इसका कुछ पोर्शन प्रिज्म के अंदर है. अगर ये वाला एटम का कुछ पोर्शन प्रिज्म के बाहर है, तो इस वाले एटम का कुछ पोर्शन, ये वाला एटम प्रिज्म के बाहर एग्जिस्ट कर रहा है, इसका कुछ पोर्शन प्रिज्म के अंदर है। तो जितना पोर्शन बाहर है उतने ही पोर्शन अंदर है। दैट्स व्हाई देयर इज नो चेंज इन द नंबर ऑफ एटम्स पर यूनिट सेल विच वी हैव कैलकुलेटेड। द नंबर ऑफ एटम्स पर यूनिट सेल इज गोइंग टू बी 6 only, right? So this is a very important point given in NCERT, right? And we can explain with the diagram given in NCERT. Now we are going to discuss the position of tetrahedral void and octahedral void in HCP crystal, and this is hexagonal prism. So we are first going to discuss the position of octahedral void. So we know that this hexagon can be divided into, ये जो hexagon है इसको हम, these are the 3 parallelogram, this hexagon can be divided into 3 parallelogram, right? Now we are discussing this position of octahedral void. This is also known as square bipyramidal geometry, right? This void, when surrounded by 6 atoms, on joining those 6 atoms there is a formation of square bipyramidal geometry. How we can explain? If I take, ये देखो यहाँ पे जो 3 atoms inside है उसमें से मैं एक edge को ले रहा हूँ, I am taking this edge, right? And in this regular hexagon I am taking this edge. If I join these edge, right, ये जो 4 एटम्स हैं इनको अगर मैं ज्वाइन करूं, 2 एटम्स जो बी लेयर में हैं और 2 एटम्स जो ए लेयर में हैं, देयर इज अ फॉर्मेशन ऑफ स्क्वायर, एंड दिस इज द सेंटर ऑफ दिस स्क्वायर, एंड दिस इज द वर्टेक्स, and this is the opposite vertex. If I combine this vertex with this square, right, this is square pyramidal geometry, and again this is again another square pyramidal geometry, and that's why we are saying that this is square bipyramidal geometry, and the center of this is a position of octahedral void. Similarly, अभी हमने इस hexagon में ये वाली edge ली, now we are going to avoid, इस edge को हम छोड़ेंगे, हम now we are going to take this edge, इस वाली एज को, और ये जो 3 एटम्स हैं इसमें से अगर मैं इस वाले 2 एटम्स को लेता हूं, विद द हेल्प ऑफ दिस 4 एटम्स आई एम गोइंग टू मेक अ स्क्वायर. द सेंटर ऑफ दिस इज अ पोजीशन ऑफ ऑक्टाहेड्रल वॉइड. इसमें आप इसको अगर कंबाइन करोगे देन देयर इज अ फॉर्मेशन ऑफ वन स्क्वायर बाई पिरामिडल ज्योमेट्री. दिस इज अ फॉर्मेशन ऑफ वन स्क्वायर बाई पिरामिडल ज्योमेट्री. एक एटम यहाँ बाहर होगा, इसको अगर हम जोड़ेंगे then again there is a formation of one square by pyramidal geometry, right? So this is a position of octahedral void. So we have taken this edge, then we have left this one, we have taken this one, now we are going to leave this one. So if I am taking these 2 atoms and here these 2 atoms, if I combine these, we are going to make a square. The center of this square is a position of octahedral void. So we have proved that these 3 are octahedral voids and they are inside the hexagonal prism. So their contribution is 1. Same way, we can make 3 more octahedral voids between, if this is A layer, this is B layer. So similarly, between this B and A layer, we are going to make 3 octahedral void more, right? So the position of octahedral void in hexagonal prism, there are 6 sides of octahedral void and all are present inside the hexagonal prism, so their contribution is going to be 1. Same way, when we are going to discuss the position of tetrahedral void, right? So till now we have discussed that with respect to this atom, the atom present at the center of regular hexagon, we have discussed that this atom is surrounded by 8 tetrahedral void, right? 1 is this one and 3 are these, right? And same way we can say that there are 4 above, right? So total 8. So I can show here what are those 8 tetrahedral void. So along this axis of hexagonal prism, if you see that this is the axis of hexagonal prism. So this is the base, or we can say vertex, and these are the equilateral triangles, right? These will form the equilateral triangle. If I combine these, there is a formation of regular tetrahedron and the center of this is a position of tetrahedral void. Same way, this is a triangular base and this is the vertex. If I combine, there is a formation of regular tetrahedron and the center of this regular tetrahedron is a tetrahedral void. So what we are saying that along the axis of this hexagonal prism there are two tetrahedral voids and their contribution is going to be 1. We have discussed about this, right? We are saying that one is here and one is above, right? So these are two tetrahedral voids along this axis of hexagonal prism. Now we are discussing these three tetrahedral voids, right? So one tetrahedral void is here and one will be above this, because we are going to place the same thing, right? So if there is one tetrahedral void here, there will be one more tetrahedral void here. So in this diagram you can check that if I am taking these three atoms, right, so this will make a triangular base and the vertex of this will be this atom, right? तो ये सेंटर के जो तीन atoms हैं इसमें से एक atom ये vertex हो गया और यहाँ पे जो तीन atoms हैं they are forming an equilateral triangle. If I combine them, there is going to make a regular tetrahedron and the center of this regular tetrahedron is a tetrahedral void, right? Same way I can take these three atoms to make a equilateral triangle, and if I combine these atoms with this, there is a formation of regular tetrahedron and the center of this regular tetrahedron is a tetrahedral void. So I can say that above this atom and below this atom there is a position of tetrahedral void, and since it is inside, their contribution is going to be 1. Same way I can say that for this also, here it is shown in the diagram, this is an tetrahedral void and this is an tetrahedral void, same way, right? So their contribution is going to be 1. Corresponding to this atom, there are also two tetrahedral void, one is here and one is here, and their contribution is going to be 1. So I have shown you that the atom present at the center of this is surrounded by 8 tetrahedral void, and those 8 tetrahedral voids are there inside the hexagonal prism, right? So their contribution is going to be 1. Now if we see the diagram given in NCERT, this diagram, right? So this is a tetrahedral void. So if we have to discuss that how this tetrahedral void is going to form, let us discuss this one. We are saying that this atom, right, here we are saying this is the atom, the center of this atom, right? So we are taking the corner atom, this one is the atom, right? Corresponding to this atom there is one atom here, and since it is also hexagonal close packing of 2D, तो इसके बाद भी दो atoms होंगे यहाँ पे. So if I combine these three atoms, there is a formation of equilateral triangle. तो वो जो दो atom हैं जो equilateral triangle form कर रहे हैं, दो बाहर हैं इसके. So if you see here in the diagram, I can show you, we are discussing about this position, ये जो atom है, right? और यहाँ पे इस atom के लिए I am discussing about this atom and two atoms are outside this, right? So if I combine these three, there is an equilateral triangle, and if I combine, there is a formation of regular tetrahedron, and the center of this regular tetrahedron is a tetrahedral void. Same way I can say that I can form another regular tetrahedron. This is equilateral triangle and this is the vertex. If I combine, there is a formation of a regular tetrahedron and the center of that regular tetrahedron will be this. So we can say that on each vertical edge, जिसको हम C कहते हैं SCP में, there are two tetrahedral void and these are shared between three hexagonal prisms. So their contribution is 1/3. So there are total 6 such vertical lines, and on each line there are two tetrahedral void and their contribution is 1/3, right? So 6 into 2 is 12, 12 into 1/3 is 4. So because of that there is 4, and because of what we have discussed corresponding to the center one, there are 8 which are inside. So the total number of tetrahedral voids will be 4 plus 8, that is equal to 12. So let us revise once more that what we have discussed till now. Total sides for tetrahedral void is equal to 20. Let me represent on this diagram. We have discussed that ये वाला एटम, यहाँ एक एटम है और दो एटम यहाँ बाहर है, इनको मिला के एक रेगुलर टेट्राहेड्रन बन रहा है. दिस पोजीशन is position of tetrahedral void. Similarly, this is a position of tetrahedral void. So first make those 12 sides at which tetrahedral voids are there and their contribution is 1/3. So these are the sides whose contribution is 1/3. ये साइड्स हैं जिनका कंट्रीब्यूशन 1/3 है. Here you can see that these are the 12 sides whose contribution is 1/3 and there are 8. तो वो 8 साइड्स कौन सी हैं? ये हो गई एक्सिस. तो यहाँ एक टेट्राहेड्रल वॉइड, बिकॉज दिस इज द ट्राइंगल, दिस इज द बेस, इसको मिलाएंगे एक रेगुलर टेट्राहेड्रन. दिस इज द सेंटर ऑफ दैट रेगुलर टेट्राहेड्रन. अगेन दिस इज अ ट्राइंगल and this is the vertex. If I combine, this center will be a tetrahedral void. Is atom, we have discussed that with respect to this, because if we take these 3 atoms and this will be the vertex, there is a regular tetrahedron, so there will be a tetrahedral void over here, there will be a tetrahedral void over here. Similarly, with respect to this also there is a tetrahedral void, there is a tetrahedral void. With respect to this atom also there is a tetrahedral void and there is a tetrahedral void. So there are 8 whose contribution is 1. So if I write that total sides are 20, so there are 12 sides whose contribution is 1/3 and there are 8 sides whose contribution is 1. So from here if I simplify, 4 plus 8, 12. There are 12 tetrahedral voids per unit cell in hexagonal prism unit cell, right? So number of atoms per unit cell is 6 and the number of tetrahedral void is 12, means per atom there are 2 tetrahedral void in hexagonal closed packed crystal. So here about octahedral void, total sides of octahedral voids is 6 and we have discussed that what are those. If I take that this is the edge, right? So this edge and this one, if I combine, there is a formation of a square and the center of this square is a position of octahedral void. अगर मैंने ये वाली एज ले रखी है तो इसको छोड़ता हूँ, मैं इस वाली एज को लेता हूँ. If I take this edge and this edge, right, with the help of that I can make a square. The center of this is a position of octahedral void. तो अगर मैंने ये वाली एज ले ली है, now I will leave this edge with respect to this edge and this one. If I combine them, I can make a square and the center of that is a position of octahedral void. Same way I can make a octahedral void over here and octahedral void over here and octahedral void over here, right? So there are 6 and each are inside the hexagonal prism, so their contribution is 1. So 6 into 1, the number of octahedral void per unit cell is equal to 6. So the number of atoms and the number of octahedral voids are equal. So we can say that there is 1 void per atom in hexagonal closed packed crystal and there are 2 tetrahedral voids per atom. This is a structure of woodsite. So woodsite is HCP with respect to anion, right? Anion here is sulfide anion, right? And the Zn2 plus ion is present in tetrahedral void. From the formula you can see that if it is HCP with respect to anion, the number of anions per unit hexagonal prism unit cell is going to be 6 and the formula is 1:1. So we can say that the number of Zn2 plus ion per unit cell is also going to be 6. Right now we have to prove that in this structure they have shown that there are 6 Zn2 plus ion per unit cell, right? So these Zn2 plus ions are present in tetrahedral void and we know that the total number of tetrahedral void per unit cell is equal to 12 and the number of Zn2 plus ions are 6, right? So we can say that 50% of tetrahedral voids are occupied in woodsite. So that can be shown here, right? So ये जो येलो कलर से शो कर रखा है, that is the position of tetrahedral void and we know that along this vertical edge there are 2 positions of tetrahedral void in which one position is occupied. Along each vertical edge you can see that lower portion में हमने symmetry के हिसाब से जो है Zn2 plus ion को tetrahedral voids में शो कर रखा है. So this 6 in number you can check here that these all vertical lines there are 2 tetrahedral void. ऊपर वाले खाली हैं और नीचे वाले सारे tetrahedral voids occupied हैं. You can count them, they are 6 and their contribution we know is 1/3. So because of that the Zn2 plus ion is equal to 2. Now along the axis, right, इस axis की बात कर रहा हूं मैं hexagonal prism के, there are 2 tetrahedral void, 1 tetrahedral void is occupied. तो 2 में से symmetrically एक occupy है यहाँ पे and same way I can say that there are 2 tetrahedral voids with respect to this, one above and one below, right? सो हियर विथ रिस्पेक्ट टू दिस, नीचे वाला अनऑक्युपाइड है और ऊपर वाला ऑक्युपाइड है, राइट? सो हियर इट्स कंट्रीब्यूशन इज गोइंग टू बी 1. विथ रिस्पेक्ट टू दिस atom present at the center, there is one tetrahedral void which is occupied, right? With respect to this atom, there is one tetrahedral void which is occupied. With respect to this atom, there is one tetrahedral void is occupied, and their contribution is 1, right? So we can say that there are 4 whose contribution is equal to 1. So total 4 plus 2, we can say that 6 tetrahedral voids are occupied. 12 में से 6 tetrahedral voids occupied है, means 50% of the tetrahedral void is occupied in woodsite. किसी बच्चे ने यह सवाल पूछा था कि सर क्या आप मुझे tetrahedral void और octahedral void की पोजीशंस बता सकते हैं? सो आई होप दैट हिज प्रॉब्लम इज नाउ सॉल्व्ड. अगर आपको हमारा वीडियो पसंद आए तो प्लीज़ इसको लाइक करें, और अगर आप वीडियो पे नए हैं, आपने इसको सब्सक्राइब नहीं किया है, तो प्लीज़ हमारे चैनल को सब्सक्राइब करें. ऐसे वीडियोस के लिए, डिटेल कोर्सेज के लिए आप हमारे चैनल में अबाउट में जाएंगे तो आपको ये बहुत सारे लिंक मिलेंगे. उसमें एक लिंक जो है वो एप्लीकेशन का लिंक है. इस एप्लीकेशन के लिंक को डाउनलोड करके आप केमिस्ट्री से रिलेटेड बहुत सारे कोर्सेज अवेल कर सकते हैं, राइट? दीज आर द कोर्सेज विच आर टॉपिक वाइज, एंड देयर आर क्रैश कोर्स ऑल्सो विच इज रिलेटेड टू जेई एडवांस. देर इज अ फुल सिलेबस कोर्स, देर इज अ कंप्लीट कोर्स ऑफ जेई एडवांस, एंड देर इज अ कोर्स फॉर क्लास 11th एज वेल एज क्लास 12th, राइट? तो मुझे उम्मीद है कि अगर आप इन कोर्सेज को लेते हैं तो आपकी जेई एडवांस में रैंक जो है वो काफ़ी इम्प्रूव होगी. सो थैंक यू वेरी मच. बाय बाय.